Hello wonderful person, this is Anton, and today we're going to be discussing a new galactic discovery that makes outer space sound just a little bit more interesting and just a little bit sweeter. But I guess more importantly, potentially just a little bit more life-friendly. And that's because for the first time ever, researchers have now identified the first true sugar ever found in interstellar space. And in this case, it was discovered right here in this molecular cloud with this particular sugar referred to as Erythrulose. And so in this video, we're going to talk about this particular study by Izaskun, Jimenez, Sarah, and the team you see here, talk about some other discoveries that are just as surprising, and discuss the overall implications from this finding. But first, I actually wanted to show you this. This is a really cool image that was created by Pablo Budassi, referred to as We Are Star Stuff, an educational infographic that was essentially inspired by Carl Sagan. And here this illustrates the cosmic origins of all chemical elements that compose human body, mapping out fundamental elements such as carbon, iron, and calcium, and actually showing us where most of them were forged. For example, cataclysmic events such as supernova. With the main point behind this infographic being a kind of a profound realization that we're literally walking, talking remnants of dead stars. With every atom of iron in your blood, calcium in your bones, and oxygen in your lungs, once forged in the intense heat of distant stellar furnaces, when many of those ancient stars reached the end of their lives, exploded and scattered these essential elements across cosmos, making us a kind of a physical embodiment of many of these very powerful cosmic processes. But everything inside of us is not just a simple element, it's obviously a collection of very complex organic molecules. And well, it turns out that quite a few of these molecules and quite a lot of these different components have now been actually found in outer space in a lot of really bizarre locations. And well, as of 2026, we've officially confirmed over 350 complex organic molecules in various molecular clouds, asteroids, and comets. As a matter of fact, Mitsunoki Araki from Max Planck Institute of Physics essentially keeps track of all of them on the website you can find in the description. He's apparently been doing this since 1996. And so discovering an organic molecule somewhere out there is no longer as surprising and as shocking. But this particular sugar is exciting and actually represents a relatively big deal for astrobiology and the idea of having life somewhere else out there except for planet Earth. And so let's discuss this discovery and the implications in more detail, starting with how this was found and where this was found. And I guess the where part is visible here. Izaskun Jimenez Serra, at the Center for Astrobiology in Spain, pointed two massive radio telescopes toward a specific location very close to the center of the Milky Way, and actually focusing on this one very well-known cloud that's not so far from the central black hole. This is a giant molecular cloud referred to as G plus 0. Well, you can kind of see the rest right there. A lot of these numerical names usually get pretty long, with this cloud being at a distance of approximately 26,700 light years away from us. But it's also an exciting location because it's extremely enriched in a lot of elements and basically represents a kind of a chemical warehouse of the entire galaxy. Lots of different stuff seems to be located here, with actual chemical reactions happening in real time. As a matter of fact, not so long ago, just a few months back actually, researchers also discovered a sulfur-based molecule in this location, referred to as 2,5-cyclohexadiene-1-thione, the largest sulfur-bearing molecule ever found in space. And since this is also a vital element for life, very often found in proteins and enzymes, discovering this in such a strange location was already pretty exciting. And so in this case, scientists were trying to find something else. And by analyzing unique radio fingerprints, or to be more exact, very specific radio frequencies that various molecules emit when they spin around, researchers once again identified exactly what seemed to be floating in this particular distant gas cloud. And that something in this case was erythrulose. And while on Earth, this is a 4-carbon sugar that you might have somewhere in your kitchen or your bathroom already. This is actually naturally found in things like, for example, raspberries, and is also a very common product in certain types of tanning products, essentially products that give you tan. So on Earth, this is technically a simple sugar. But while scientists previously detected molecules like glycololdehydes, molecules related to sugars, these were not considered to be true sugars. In other words, they were sugar-like derivatives. But in this case, erythrulose is the first definitive saccharide discovered in interstellar medium. In other words, this cloud literally tastes sweet. But why exactly does this matter, and why do we care if it tastes sweet or bitter, or that it might taste like raspberries? Well, naturally, this all comes back to the idea of origin of life. Because as we know today, sugars are absolutely essential for all known biology. Literally everything we know today, or everything that we call life, requires sugars. And they do have multiple roles. They provide energy, they form various structures, and most importantly, they form the backbone of DNA and RNA. In other words, without sugars, you cannot function, and you cannot have the genetic code that allows life to replicate. But the problem is that for a very long time, there was a kind of a chicken and the egg mystery. And that's because on Earth today, living organisms already use complex enzymes to create sugars, in some sense implying that enzymes potentially came first. But experiments trying to recreate conditions of early lifeless Earth have always struggled to produce a lot of these sugars naturally, suggesting that their origin would be very difficult to explain. And because these sugars would be required to produce these enzymes, it was not clear what started what and how exactly any of this began. And so if early Earth could not produce these sugars easily, where exactly did they come from? And well, right here we may have our answer. They might have just come from space. With this cloud potentially containing at least 8 times more of these sugars compared to 3 carbon sugars previously discovered. And essentially proving that chemical reactions in outer space do not just involve single atom carbons, and can create something much more complex, with the evidence in this case suggesting that this molecule very likely forms from simpler 2-carbon molecules on the surface of interstellar dust grains, with the reaction maybe resembling something like this. And while along with many other discoveries from, for example, asteroid Bennu and Ryugu, we now know that a lot of stuff potentially came from outer space. For example, various other sugars such as ribose found in RNA and glucose used for energy seem to be also present in large numbers in various meteorites. But the discovery of this molecule also confirms that they potentially existed even before the solar system formed, and most likely started to form inside the early interstellar cloud long before the Sun or planet Earth even existed, with scientists now estimating that up to 50 million metric tons of erythrulose could have been delivered to young Earth during the late heavy bombardment 4 billion years ago, essentially implying that early Earth was seeded with massive amounts of organic molecules, which then allowed life to evolve. And so, what does this mean for astrobiology and the search for extraterrestrial intelligence? Well, first of all, this confirms that, in theory, life could be common, because the ingredients for biochemistry seem to be all over the place. Second, it tells us a little bit more about these prebiotic signatures. So basically, when it comes to biosignatures, instead of looking for oxygen or water, we can instead look for these prebiotic molecules, such as various sugars, that in theory could imply that some kind of a planet out there might possess the ingredients needed for life and thus could be already habitable or will become habitable in the future. Lastly, this also leads us to some potential answers in regards to the origin of life on Earth, because we know that this particular sugar can easily transform into threose in water. And threose is a key component of what's known as TNA, or threose nucleic acid, which scientists believe might have been a much simpler, much older relative of RNA, serving as a kind of a precursor to RNA and of course DNA. And so finding erythrulose in space tells us that the ingredients of this pre-RNA world seem to be available everywhere right from the start. Or once again implying that, technically, if a lot of this stuff lands on a planet somewhere out there, and that planet also has liquid water, there might be a chance that something very similar might happen there, and life could kickstart at some point. But as always, at least for now, this is just theoretical, because the actual story of origin of life is still unknown. But when it comes to this cloud, researchers are also planning to use the James Webb to try to find additional sugars and additional molecules inside of it, and to essentially see what else they can discover in this very strange, very ancient molecular cloud that seems to contain way more than we ever imagined. But at the same time, this has also now changed our view of space as being this hostile, deadly, empty void into something that actually seems to be the opposite. Something that serves as a kind of a celestial laboratory where recipe of life is actively being cooked and is then delivered to various planets. And so, going back to that initial picture I showed you, we're not just stardust anymore. On top of this, we're also basically space sugars and cloud molecules. Something that potentially existed in a galaxy for billions of years until it got delivered to a planet like Earth. Anyway, we'll definitely come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.